Today we are going to be learning about graphing polynomial functions. So you will be able to state the end behavior of a polynomial function using degree and leading coefficient, and finding the x and y-intercepts of a polynomial function, and then identifying the multiplicity of the zeros from the graph. Now this lesson may take longer than just a Wednesday, so you may want to watch part of it today and then do some homework and then watch part of it tomorrow, but just working at your own pace. So let's go ahead and get started. You have the handout, so follow along with this. The end behavior is going to be described as the behavior of the graph as x approaches positive or negative infinity. So we're going to denote that by like positive infinity, but usually we don't put a plus sign for positive infinity, but for negative infinity we'll have a negative sign. Okay, so end behavior, that's talking about what's happening, like for x squared, this would be our end behavior, where what's happening at the ends, at the arrows. So in that one, as x is going to positive infinity, the y is going to go to positive infinity. So that's what we're talking about, what's happening at the arrows. So you're going to be given a function that's a polynomial. So it could be x to the third, it could be x to the fourth, it could be x to the fifth, but you're going to be able to describe that polynomial, the end behavior of that polynomial. Okay, so what determines the end behavior is the degree and the leading coefficient. So say you have like y equals 3x to the third plus x squared plus 5. Okay, the degree of that is the highest exponent. So the highest exponent in this example, the degree would be 3. So that's right there, the highest exponent. And then the leading coefficient is the number in front of the x that has the highest exponent. So in this case, it's 3. Sometimes they're going to give you a function when it's not in standard form, meaning it's not going 3, 2, 1, 0. It may be 2, 3, 1, 0, and you need to be able to pick out the x to the third, no matter where it is, or x to the fourth, whatever the highest one is, that's your degree. So you need to write it in standard form where it's in descending order. Okay, so end behavior. The first one we're going to do is when we're looking at when the degree is odd. So think about functions that have an odd degree, polynomial functions with an odd degree. So that means the degree is 1, 3, 5. So the function that you recognize right now, you know end behavior would be x. So when you have degree, that the degree of that one would be 1. Okay? And this one, the leading coefficient is positive. So y equals x, positive leading coefficient. So when you think about the graph of y equals x, that's going to have a positive slope. So it's going to be going up and to the right. So a positive slope would look like this. Okay? Now, any polynomial that has an odd degree and a leading coefficient that's positive is going to have that same end behavior. So what's happening at the arrows? So like y equals x to the third. That one is going to have the same end behavior. It's going to be going up there and down there. And then there's going to be something that happens in the middle, depending on what the x to the third looks, what else it has with it. The parent function is going to look something like that. So now we have to be able to describe the end behavior. So always think back to what y equals x looks like for an odd degree with leading coefficient that's positive. So the end behavior, as our x is approaching positive infinity, so that's going in this direction right here. So as I'm going in that direction to the right, what is happening to f of x, or y? Well, my y's are going up. all the way to infinity. Okay, so my f of x is approaching positive infinity. In your book, they do it the other way around. They say f of x approaches infinity as x goes to infinity, but make sure you write it the way we're doing it. Okay, this is the way I expect to see it in your homework. So now we're going the other direction as x is approaching negative infinity. So I'm thinking about my x values. As I'm going to the left, where are my y values going? Well, they're going all the way down. So they're going to approach negative infinity. So as x is going to the left, my f of x is approaching negative infinity. All right. So now we're going to look at this again, an odd function, but my leading coefficient, what's in front of my highest degree, is now negative. It doesn't have to be a 1, it can be anything, -3, -2, whatever that is. So when we go back to our most basic case, that would be negative x. If you think about negative x, that's a line with a negative slope. So it's going down and to the right. Okay. When I have y equals negative x to the third, that's going to have the same end behavior. It's going to be going up there and down there. And then something else is going to happen in the middle. Okay, so we're just focusing on the end behavior right now. We'll talk more about how to graph the polynomial towards the end. Okay, so we are going to have our end behavior as x is approaching positive infinity. So again, I'm going to the right. What is happening to my y values? Well, my y values are going down to negative infinity. As I'm going to the left to negative infinity, my x values, what is happening to my y values? Well, they are going to positive infinity. So with odd functions, your end behavior is always going to be going in opposite directions, either up and to the right and down to the left, or up and to the left and down and to the right. Okay, so always opposite directions when you have an odd degree. All right, now we're going to do the same thing, but for an even degree. So now we're looking at even degree. So think about functions that you know what they look like. Well, we just did a whole unit on even degree functions, the quadratics. So you know what y equals x squared looks like. That's our parent function. So I'm going to draw that. So your parent function, you can always go back to that. And even if you have y equals x to the fourth, you're going to have the same end behavior, and something else will happen in the middle. We don't know what yet. It could look like that. It could look like a wider parabola. But something is happening in the middle, and we're just focusing on the end behavior. Okay? But the end behavior will be the same anytime you have a positive leading coefficient and an even degree. So let's look at our end behavior as x is approaching positive infinity. So I'm going to positive infinity. F of x is approaching positive infinity. As x is approaching negative infinity, so I'm going to the left, f of x, or my y values, are approaching positive infinity. So with my even degree polynomial, I'm always going to have going in the same direction, have my end behavior the same direction. So if the leading coefficient is positive, they're both going to be going to positive infinity. If it's negative, we're going to talk about that now, they're both going to be going to negative infinity. Okay, so think about the equation of an even degree that's negative. So like negative x squared would be an even degree with a leading coefficient that is negative. So that is a reflection over the x-axis. So that would be the graph of that function. If you had y equals negative x to the fourth, we aren't talking about what happens in the middle, but the end behavior is going to look like that. And then something else is going to happen in here. It could look like that. Just depends on if there's anything else added here. Okay. But the end behavior is what we're focusing on. So again, going through the end behavior, as x is approaching positive infinity, so I'm going to the right, f of x is going to negative infinity, so I'm going down. As I'm going to the left, f of x is going down as well. So as x approaches negative infinity, f of x approaches negative infinity. And then here's a little comment down here at the bottom. There are going to be no more than n-1 turning points, or max and mins, for your function. So we're going to talk about how to graph these functions, but for like x to the 4th here, this last one, we have 1, 2, 3 turning points. So that is the most that I can have for turning points. Otherwise, if I turn again, I'm not going to have the right end behavior. And up here, we only had 1 turning point, which is n is 2, so that's the most turning points that I can have, and that's what I have to have for a quadratic. Okay, but for a quartic, when it's a degree 4, you could just have like a wider one, so it's a turning point, just 1 turning point. So you don't have to have n-1, but for even degree, you're going to have an odd number. Is what you're gonna know that. Okay. Moving on, let's do one example here. And remember, you can always come back and pause the video to try again and try to understand it, so go at your own pace. So what is true about the degree and the leading coefficient of the polynomial function whose graph is shown? Okay, so look at your graph over here. There's a few things you want to notice. Okay, first, our end behavior, they're going in the same direction. Okay, so look back at the last page, which degree had them going in the same direction. If you look back there, you'll notice that the even degree had your end behavior going in the same direction. So we know the degree has to be even. So we have eliminated A and B. Now, the end behavior is both going down. They're both going to negative infinity. So what determines that, which direction they're going, is if it's opening up or opening down, is if it's the leading coefficient is positive or if it's negative. Well, if it's negative, then they're going to be going down. If you look back at your notes, you'll see that. D is your answer. Okay, now we're going to shift into getting prepared to graph these functions. So we're always going to keep in mind the end behavior when we're graphing. I'm always going to ask you what is the end behavior of the graph before you graph it, because that's going to determine if you found your zeros correctly and so on. Right now we're going to be using our calculator to help us out with finding our points. But we will eventually learn how to find those zeros by factoring. So we've talked about this next slide a few times, that these words all mean the same thing, but I wanted to write it out again because you're going to keep seeing this. So if one of the following is true, then they are all true. So if x equals a is a 0 of f of x, then we also know it's a solution to the equation f of x equals 0. So that means when you have an x-intercept, so like number 4 says it's an x-intercept. And then number 3 is saying that x minus a would be the factor of f of x that gives you that 0. So remember, x minus a equals 0 would be one of the factors, and then you would add the a, and you get x equals a. So that's the factor. If you know a 0, then you can write it as a factor x minus the 0. if you know the factor or anything else, one of those, then you know that X-intercept is also what A is. So it's a 0, it's a solution, it's an X-intercept. And then you can write it as a factor. Another word we use is a root. So those are all things that you'll see. Okay, this is something new that we haven't talked about yet, and that's called the multiplicity. So back when we were factoring before, we would get to a point where we would have like x minus 2 equals 0, or x minus 2 squared equals 0. And you would only get 1 0, okay? So that would be like on a quadratic, x minus 2, the 0 would be 2. So what it's looking like is a parabola that's got the vertex on the x-axis, okay? So what's happening there is it's going to have a multiplicity. So it's happening twice. That 0 is happening twice. So that tells us what happens at the x-axis. Okay, so if it occurs more than once, it is a multiple 0. The number of times it repeats is called a multiplicity. So in this case, the multiplicity is 2. If the multiplicity is odd, it's going to cross the x-axis. If the multiplicity is even, it is going to come down and touch the x-axis and go back up. Okay, so in this case, it was an even multiplicity because it was 2. Multiplicity was 2. So it came down, it touched, and then it went back up. If it was an odd multiplicity, you might see something like x minus 3 cubed. Okay, what's going to happen is at that 0, at 3, it's going to come down whichever direction it's coming. It's going to cross the x-axis at that 0. Okay, so it tells you it's going to cross it. You're going to have to sketch some of these graphs based on zeros that I give you, and what happens at those zeros. Okay, so this may be x minus 3 squared and then x plus 2. And so then it might come back over here, and this would be a multiplicity of 1. It's not a multiple 0, so it's still an odd multiplicity. So it would come through and it would cross at that one as well. Okay, so it crosses at an odd multiplicity and touches at an even. So always think back to the graphs that you know. So like y equals x, that's going to cross the x-axis. It only happens once, so it's crossing. If it comes down and it touches, it's an even, like our quadratic. So this is an idea that we will keep talking about throughout this unit as we're graphing our different polynomial functions. Okay. So this one, again, was a multiplicity of 3. And that would be a multiplicity of 1. Okay. So you would say your 0 is 3, multiplicity of 3. So it's kind of like you have 3 3s. So it accounts for that. All right, now we are ready to graph our functions. So go ahead and get out your graphing calculator, because you're going to use that to help you graph, because right now we don't have enough information we don't know enough about how to factor and everything to get these answers without using the calculator. Okay, so we're going to graph these. The things I'm always going to ask for is your X and Y intercepts, and then you're going to use the table in the graph to find your additional points. Also going to ask for the end behavior. When we first start, we're going to talk about the end behavior. And make sure that you are able to find the Y-intercept by hand. So you can find this by hand. Okay, remember, finding the Y-intercept is where it crosses the Y-axis. So X is 0, so you plug in 0. And if you plug in 0 here, these are all going to go away, and you have -3. Okay. So first thing we're going to talk about is end behavior. So end behavior, the things that are important are the degree and the leading coefficient. Okay. So the degree of this polynomial is 3, which is odd. And the leading coefficient is a -1, so that means it's a negative. So now you're going to go back and think about your end behavior of a line. Okay, so we're an odd function, or an odd degree. And so if you go to the line y equals -x, you're going to have the end behavior where you're going up and to the left and down and to the right. Okay. So that's your end behavior, up and to the left, down and to the right. So just kind of make a sketch for yourself. That's what's going to happen at the end. Okay. So something else is going to happen in the middle, but that's eventually where we're going to end up going. Okay, so y-intercept by hand, plug in 0. So I get the point 0, and then back up here we see -3 will be our y-intercept. So we know it's going to cross at 0, 1, 2, 3. Okay. Now you're going to use your calculator to find your x-intercepts. So graphing calculator is what you're going to need. You can use Desmos if you don't have one at home, but you should have some time to work on this in class. Okay, so x-intercepts in our graphing calculator. So we're going to go to our graphing calculator now and hit our y equals button, clear out any functions that we have in there, and we're going to plug in that function. So we have -x to the third plus x squared plus 3x minus 3. So now we're going to look at the graph. Okay, this is fine, but I'm going to get it to a standard window, the zoom standard, so it looks like yours. Okay, so now you see something going on in your x's there. It's kind of hard to tell how many x-intercepts we have, but we should have 3 here. This looks like it's crossing twice. So you may want to zoom in farther, make your window smaller, so maybe -5 to 5 and -5 to 5. Okay. You may want to make that smaller just so you can see it a little bit clearer when you're finding your x-intercepts. Okay, so those are not crossing right at the integers. So you're going to have to go back and find the zeros. So if you don't remember that, you're going to hit second calc, and you're going to do this 3 times because you have to find all of the zeros. So hit 0, and then remember to go to the left side of that. So if I'm looking for this left 0, the left side is going to be above the x-axis, and then the right side is below the x-axis, and then in the middle. So that 0, and I'm just going to write it over here for your reference, is -1.73. And we'll just go to, let's see, 3 decimal places, I guess. So there's the first 0. Then we're going to do this 2 more times. So second calc, 0. We're going to go to the left side. So we're already on the left side, but I'm just getting this a little bit closer. So we're on the left side, then we want to go to the right side, and you want to be careful here. You want to be above the x-axis, and then guess. Okay, so that one was an integer. It was 1, 0, so that's our next point, 1, 0. And then we do this one more time, second calc 0, we're already on the left side, which is above the x-axis in this case, and we need to go to the right side, which will be below the x-axis, and then back to the middle, that's our 0. And so we see a little bit of symmetry there. This one is 1.732, 0. Okay, so we have those points, but then we want to have a few more points to be able to graph the rest of the graph. So I'm going to go to the table to pick a few more points. So go to a second table, and then we'll go up a little bit here. We find some more points. So let's graph what we have so far so we know how many we need. So we have 1, 0 up there, and then we have a 1.7. So that would be about like right here. And we have a negative 1.7. Okay, so we need some more points in there. Let's just go ahead and put like negative 2, 3. So that's going to get us something up there. And then negative 1, negative 4. We already have 0, negative 3. 1, 0 we already have. And then 2, negative 1. So we want to get things to the right of our x-intercepts and to the left of our x-intercepts and anywhere in between to give us just a little bit more of an idea of what's happening. So let's graph those points. So we have negative 2, 3. And we have negative 1, negative 4. So that gives us a little bit more of an idea of the shape of this. And then we have 2, negative 1. Okay. So now we're going to be graphing this. And we already kind of have a picture of what it's going to look like. Okay, so this is coming down here. And then it's going to come back up here. And then come back down here. So you have enough points to give you a good shape, a good idea of what it's going to look like. Our end behavior worked out the way we said it would. And that's about it for how much you need to do for graphing right now at this point. Okay, so you're using the graphing calculator to find some additional points to give you a good graph. Okay, we're going to do this one more time to give you an idea of an even function, an even degree function. Okay, so first thing we're going to talk about is our end behavior. So our degree, our highest exponent is 4, which is even. And then our leading coefficient is what's in front of the x to the 4th, which is 1, which is positive. So remember, I care about whether the degree is even or odd, and I care about whether the leading coefficient is positive or negative. Okay, not odd or even. So be careful with that. So end behavior, think about your even function like x squared, and it's positive, so that's our x squared. So our end behavior is going to be going up on both of them. So as x is approaching positive infinity, f of x is going to positive infinity. Negative infinity, f of x is going to positive infinity. So that's our end behavior. So at the end, we should have something looking like that. And now we're going to find our y-intercept. So you should be able to find this by hand. Plug in 0. All of those x's are going to go away, and you're going to have 4. So our y-intercept is 0, 4. So that's going to be up here, 1, 2, 3, 4. And then you're going to find your x-intercepts by hand, or by using the graphing calculator. Okay, so pull up that graphing calculator again. You're going to plug that in. So we have x to the fourth minus x to the third minus 4x squared plus 4. So graph that. Okay, so our end behavior makes sense. You might want to zoom back out again, but I think this will give us a good picture, enough information, that is. But if you're not sure, it's always good to zoom out just to make sure. So zoom standard. So in your calculator, that's why we talk about end behavior, because if you didn't see, if you only saw like from 0 to like the x-axis, the positive x-axis, then you wouldn't know what happened over there on the left. So you always want to be careful that you have the whole graph in your window. Okay, so this one is showing, so now we need to find those x-intercepts. It looks like we only have 2 for this one, which is okay. So we have 2 x-intercepts. So find your zeros. You're going to do it the same way. I'm just going to write them. I'm not going to go through it again up here. So 1, 0 is one of them, and the other one is 2.3830. So finding the zeros the same way you did the last time. If you need to see that, again, check with someone next to you to get some help with that. Okay? So we're going to graph these so we have an idea of what other points we need. And then, so 1, 0, and then 2.3, that's about right here. And remember to look at your end behavior. Okay. Now we're going to look at the table. Okay, so second table to find our other points. So we have our xy, and it looks like -2, 12 would be a good point. -1, 2, 0, 4 we already have, 2, -4, and looks like 3, 22, but that's not going to be able to be graphed, but it's going to tell us which direction we need to go. So I'm going to put it there just for some reference. Okay, so now we're going to graph that. So -2, 12, and I'm going to close this out so we can see the rest of this graph. Okay, so -2, 12. So we're going up here. That's going to be 2 above. So maybe you would want to change the scale on this graph. But we're going to get a good enough picture here. So -2, 12, -1, 2, 2, -4. So we're at 1, 2, 3, 4. And then 3, 22. So that's just telling us that at 3 we're going to be up here way off the graph. Okay. So here we come down, and then it kind of curves around here. If you look back at the graph, it kind of curves up. So you go back to the graph that was on our calculator. This is what it looked like. So we're kind of trying to sketch that same thing. So it kind of went up there, and then we went down through the x-axis, and then we got to this point here and went back up, and then we're going to keep going up. So that's what that end behavior helps us with, is knowing which direction we'll have to go through those zeros and end up going forever. So that is the graph of the equation. So that's about it for day 2. This homework will be due on Friday. So if you didn't finish the notes in class on Wednesday and you finished them on Thursday, you should have time now to work in class. You're free to work with your table partners or people around you, but you need to make sure you're working. And this homework, if you have questions, Wednesday or Thursday, Mrs. Gordon is here in the morning and after school, except for Thursday morning. She's not here on Thursday morning. But there are other math teachers that should be able to help you. Okay? So you are now free to work on your homework. And on that homework, be sure to get some graph paper so you have good graphs. I don't want to see sketches. There's plenty of graph paper over there. And make sure you state your X and Y intercepts just like it says on the homework. Okay, that homework is due on Friday.